on log and parent functions. Going to graph them. So to start, we're going to graph a log parent function, which is f of x equals log x, and then we're going to graph the inverse of it, which is an exponential function of f of x equals 10 raised to the x power. Now let me just show you what these kind of look like. The log parent function is going to look like that. It's going to cross through the point 1, 0, and it's going to have an asymptote, a vertical asymptote at the line x equals 0. Now, the inverse of it, which is 10 raised to the x power, is going to be a growth function, and it crosses through the point 0, 1, and it has an asymptote on the x-axis at the line y equals 0. Notice how for the inverses of these two functions, the x's and the y coordinates are flipped, and they're also reflected across each other across that diagonal line of y equals x. Let's go ahead and graph a couple of these. Let's graph log base 2 of x. To graph this, I'm going to first graph y equals 2 raised to the x, and then doing the inverse, switching the x and the y, will allow me to then graph the weird log base 2 of x. Because I think it's a lot easier to find your ordered pairs of the exponential 2 raised to the x instead of just doing the log base 2 and graphing that. Okay, let's do some points. Let's plug in -2, -1, 0, 1, and 2. And our outputs would be 1/4, 1/2, 1, 2, and then 4. Now making the inverse graph, all you do is you just switch the x's and the y's of each of these ordered pairs that we just made. So we're going to have 1/4, -2, 1/2, -1, 1, 0, 2, 1, 4, 2, and it's as easy as that. Putting those on the graph look like this. Connecting our dots. And notice how it increases to the right and has that asymptote right there. The domain is everything above 0. The range is all real numbers. The end behavior, as x goes to positive infinity, the y value is going to positive infinity. Now as x doesn't go to negative infinity, as x goes to 0, the y value is going to negative infinity. And then the x-intercept is the ordered pair of 1, 0. And the vertical asymptote is at x equals 0. Moving on. Let's go to this next page. Let's do a little bit tougher one now, where we have a base of a fraction, and then we also have some transformations being applied. To start this problem first, I'm going to write down the parent function of 1/2 raised to the x power. After coming up with those ordered pairs, I am going to flip them. I'm going to do the inverse of them, and that will give me y equals log base 1/2 of x. And I'm going to do one more thing with them after. Let's first just come up with our points. -2, -1, 0, 1, and 2. Plugging them into the 1/2 raised to the x power. We get 4, we get 2, we get 1, 1/2, and 4. Remember, whenever you raise something to a negative power, it flips the fraction. Now flipping them around, doing the inverse of these points, switching the x and the y's, we get a new function. So we get 4, -2, 2, -1, 1, 0, 1/2, 1, and 1/4, 2. Now we have other stuff being applied. We have a +9 and a +4. That +9 is moving left 9, and that +4 is moving our graph up 4. Now what we need to do is take our red table, and we're going to take our x values and go left 9 with them. And we're going to take our y values and go up 4. And that's going to give us a third table of x's and y coordinates. And this will be our final table, I promise. Going left 9 from 4 brings us to -5. Going up 4 from -2 is +2. Going left 9 from 2 is -7. Up 4 is 3. Left 9 from 1 is -8. And then up 4 to 4. Left 9 from 1/2 is -8.5. And then up 4 to 5. Left 9 from 1/4 is -8.75. And then up 4 to add 6. Going to our graph now. -5, 2. -7, 3. -8, 4. -8.5, 5. -8.756. And it's going to follow that pattern. Not crossing the asymptote, which is right here. Filling out our domain. The domain is everything, all the x's above -9, to the right of -9. The range will be all real numbers. As x goes to positive infinity, the graph is actually going to -infinity. And as x goes to the left and stops at -9, the graph is actually going to positive infinity. The x-intercept. We might need to figure that out in a second, but I know the asymptote is a vertical line at x equals -9. The x-intercept we will skip for now since we haven't learned solving equations yet. But if on our table we ended up with something with 0 on this right side, this would be our x-intercept on the left. But it looks like it might be somewhere over here. I don't know the exact value, but again, I don't want to show you how to solve this equation just yet. Let me know what questions you have on graphing these. Just to recap, we start with the exponential function in blue. Then we switch the x and the y to find the inverse in red. Then we had to transform our graph left and up. Now I do want you to know how to graph these without a calculator, because obviously you could just type this in the calculator and get your table. Have a great night.